Hello everyone, welcome to our first lab. This is a lab 1 data visualization. It's an introduction in how to use Python. To be more specific, we'll be working on Colab. So if you want to access Colab, you can just go to Colab and you create a new notebook. And it's quite simple. There will be only two types of chunks that you can use, whether you want to write code or text. Right? So this is for code and the one is for text. So if you go to the to Brightspace, you can access Lab 1. So Lab 1, right now it only has text, but it doesn't have code because we're going to work on that right now. Okay, so once you're in Colab, let's get started. First thing you do, every time you want to work with Python, is you need some libraries. We need to import the libraries. So let's import pandas. Pandas it's really popular in data science. Why it is important? Because we use it to manipulate data. When you want to import data, export data, transform your data, typically you will use pandas. So the syntax is simple. It's just import the name of the library, and that's it. I mean, you can leave it only with this line of code. However, it's common to add an alias to the library. So for example, here is import pandas as PD. So every time that you refer to the pandas library, you can use only this alias PD. So it saves, like some characters in your code. So that's the reason why we use this the alias. Okay, so in addition to pandas, we will use a visualization library, which is matplotlib, .pyplot as PLT, and Seaborn too. So these two are visualization libraries. There is another one. Plotly Express as PX. So Plotly, the main, I mean, Matplotlib, it's very popular. I recommend you to use Matplotlib when you wanna create like quick plots. Seaborn uses Matplotlib, but typically plots are a little bit nicer. They look better, but in general they will be the same idea. Now in the case of Plotly, in the plot in this library, what you get is interactive plots. So you can, if you hover the plot, you can see some labels. You can zoom in, zoom out. So they are really nice when you are creating like a dashboard, or when you're doing like an EDA using plots. It's really useful. The Plotly Express library. All right. So once you input the libraries, you run this chunk of code. So now these libraries are available here. Okay, so let's get started with bar charts. So when do we use bar charts? I'm sure that you have seen them all the time. So typically we create bar charts when we have categorical variables. For example, this is sample number 1. Here we're analyzing the top 5 best selling cars in the US in the year 2024. So the variable here, the categorical variable, is the car. Which car? So we have Ford F-Series, we have Chevrolet Silverado, Toyota, Honda CRV, right? We have the 5 most popular cars in the US in 2024. So this is a categorical variable, the possible values. Now, for that categorical variable, we have the frequency of sales, or the total amount of sales. So we know the number of units that were sold for each of those cars. But again, this is the bar chart is for a categorical variable. You can sometimes you can use it for a discrete numerical variable, but that's when the discrete variable has few possible outcomes, few possible values. For example, let's say that I'm grading a quiz, right? And the grade, the grading system, the unit that I use is like the number of correct answers, right? Number of correct questions. So if there are 5 questions in total, then the possible grades are 0, 1, 2, 3, 5. So even though that variable it's numerical, it's discrete, it has few possible outcomes, only from 0 to 5. Then a bar chart makes sense, right? But if you have a continuous variable or a discrete variable with multiple, with different values, then that's a problem. It's not recommended to use a bar chart. Okay, so let's input this information. We don't have a table here. We need to create either a data frame or some list, and to input the name of the cars and also the number of units. So we need the sales. Here the generative AI is helping us, which is fine. So anytime you want to create a list, you use brackets. So here I'm gonna create the list with the sales, right? So these are the values of the sales. And in addition to that, we need the cars. So for this purpose, we're gonna create another list, but in this case, we need to add the names of the cars. So we have Ford F Series, then we have the Chevrolet Silverado, then you have the Toyota, I'm just going to shorten the names a little bit. The CRB, and the Model Y. Right? So we have created our list with information. Now let's create our first bar chart. Since I'm going to use Matplotlib, that's PLT, so it requires two parameters. In the x-axis, we need the label, right, of the variable, the possible values of the variable. So in this case, it will be the cars, the name of the cars, and we also need the sales. That's the frequency or the total number of sales, right, the value. So that will be that will define the height of the bars. So we create our first bar chart, and I show the information, right? So in this case, it's working because I shortened the names, but sometimes if let's say if I increase the number, the names, for example, here instead of CRB, I have Honda CRB, and instead of the RAV4, we have Toyota RAV4, then there will be a problem with the labels here, because it's going to be like crowded, right? I miss this one, Tesla. So there are possible solutions for that. We can like do like an angle here, that's an option, or we can create a vertical. This is a vertical bar chart. We can create a horizontal one. So let me do that. So instead of having this, we just add an H to create a horizontal bar chart, and then we don't have the problem with the with the name of the of the values of the variable. All right. So this is a simple bar chart. Now, this one was easy to create because the information is given. This is a table actually. Even though it's not a table format, it's a table. But sometimes you need to count first or sum the observations for each value of the variable, and then you need to create the bar chart. For example, here, we're going to use a new data set in example number 2, Titanic, and we are going to get that data set from Seaborn SNS, which is a visualization library that we loaded previously. Here, Seaborn as SNS. We're going to load the Titanic dataset. Now I want to ensure that the Titanic dataset is a data frame, and there is a reason for that. Because when you use pandas, it's easier to work with data frames. But because if you load the dataset initially, it has a different data structure. Okay, so we have Titanic DF, it's a data frame, and let me show it to you. It has information about the passengers. We know whether the passengers survive or not. The class, we know the different information, gender, the age, the fare, right? If the person was alone or not in the Titanic. Typically, you will see this data frame in classification problems. So they're trying to sometimes to train a model to be able to predict whether a passenger is going to survive or not. In our case, we'll only just create some plots here. So let's do bar chart for the variable alive to count like how many people survive. So we're gonna first we need to create to count like the number of yes and number of no, so to see how many people were able to survive. So we do that with the data frame, the variable of our interest, which is alive, and then to that variable we're going to do value counts. So what it does, this method, the value counts, is that it's going to count for each value of this variable the number of observations. So we're getting this table here. So we know that from our data set, we know that 549 passengers did not survive, while 342 survived. Now with this table, we can create our bar chart. So PLT bar. Now in the x-axis, we need the name of the variable, the possible values of the variable. So in alive, there are two values, no and yes. In the y-axis, we need these values, right? The count. So what we're gonna do is like from this object that we're calling alive counts, we can take the in these data frames in general. You have the columns. The name of the column here is count, but you also have names for the rows, but we call those as index. That's the index. So here I'm gonna use alive counts dot index because I want to get the name of the row. That will be the no and the yes. And also we want from that alive counts, we want the values. So that's what we're getting here. So now we see the information that we already know. So number of passengers that did not survive and the number of passengers that survived. So it's the same information, just using a plot. So we can do the same using Seaborn. We can do the bar plot, and it has the same parameters. So the x alive counts dot index, and the y the values. Even for Plotly Express, you can do the same. It's px. I'm sorry, px dot bar. Same information. The x, we have the index, and for the y, the values. But the difference with this plot is that it is interactive. Even though in this case the interactivity were not that much value, in general you can get like really interesting variables, plots. So let me show you. You can like zoom in here. If you double click, it will return to the original plot. A nice feature maybe, even though this is a simple plot, is that if you hover, then you can see the values, like the exact values for that for each bar. So this one for x equal to no, y is equal to 549. For x equal to yes, the y is 342. So maybe that's one of the nice things with when you have interactive plots. Okay, so far we have used a bar chart with a single variable, but it is possible sometimes to add even more variables in our analysis, more categorical variables. Now let me show you another way to do this. Let's maybe change the variable. Let's use gender or sex in this case. That's the name of the variable. So from C1, I'm going to use a count plot. No, what is a count plot? It's a bar chart. But the next thing or the next feature of the count plot is that you're going to avoid this intermediate step of like creating the table with the counts. This plot is going to do it. That's part of the plot. So let's see how it works. So this is for sex or for the gender. So now we know the how many passengers were male and how many were female. And if you want to add one more variable, we can use colors to add another categorical variable, because here the sex, it's a categorical variable. So we can use the hue parameter in this method, the hue parameter. So hue equal let's see alive. So let's combine these two variables. Let's see for per gender. We'll see by gender how many of those passengers survived and how many did not survive. Now we have our new plot combining the two variables by using this hue parameter. So now we can see that in the case of a female, the number of females that survive it's way higher compared to the male. And I'm talking about like using as reference each gender. So when you're doing that exploratory analysis and EDA, now you start asking questions like why this is happening, does this make sense? So we're not experts, but I mean, if you have watched movies, like regarding with accidents involving chips, you know that typically it's like, okay, so female and children, women and children, they will have the priority when there is an accident, right? So most likely that's the reason why we see here these results. Now remember, this is exploratory data analysis. So here is where you start understanding your data, but you don't make you don't draw conclusions right away. So if you want to arrive to some strong conclusion, you need to perform some statistical analysis. However, in this case, the difference is huge. So I will give it a pass in terms of for the formality. But again, in general, the idea here is just to have some hypothesis. All right. Now let's. So far, we have been working with categorical variables, right? The gender, whether alive. Now let's start working with continuous variables. So for that purpose, instead of bar chart, we're going to use histograms. And that's the big difference between bar charts and histograms, because they look similar. Both of them, they have bars. But the main difference, if you check a bar chart, there are some spaces, like between one bar and the next one. There can be spaces because the variable is categorical or discrete. But in the case of histograms, you always have numerical variables, and they are continuous or sometimes they are discrete. Okay, so for this specific example, I'm gonna upload another file. This is a third example. We're gonna analyze life expectancy in our Brightspace. if you go to contents, you will find the file. Let me show it to you real quick. This one, Gapminder. Okay. So now, the first thing that we will do is that we need to upload the file. So in order to do that, we click here in the upload folder. There is a file with the arrow. So you need to find your file. In my case, it's in downloads. So it depends if you change it to a different folder. So once it is available, now you can save, or you can create a data frame from that file. So df is our data frame equal to pd, because we're using pandas, read, and we will use read CSV, right? Because our file is a CSV. However, please notice that there are different options here. There are different methods to be able to import different files. So we have here SAS, SPSS, Excel file, SQL, JSON files. There are different formats here. Again, here we will use CSV because that's our extension, right, for the Gapminder file. So we'll use the read CSV and the name of the file. You can tap, right? You can use the predictive text here if you want, that's fine. Please make sure that the name is exactly the same. In my case here, there is a problem because it's using a different name, life expectancy data. However, the name of the file, the real one, is gapminder.csv. So you gotta be careful even with the predictive text from Gemini, because sometimes it will make some mistakes. It's gonna get better, right? But again, you need to double check always the AI that you are using. Okay, so let's explore a little bit our data frame. So here we have the Gapminder. We have country, year, the population during that year, the continent, life expectancy, which is our variable of interest. We also have the GDP per capita. Okay, in this problem, we will focus on the life expectancy of the countries. So we have different countries. For the same country, we have multiple values because there are different years in our data set. So we can kind of like describe our data set using the method describe to see all the variables that we have, especially these are the numerical variables, and we can get some descriptive statistics, such as how many observations you have, the mean value for that specific variable, the minimum, the maximum, and we also have the percentiles, the quartiles, Q1 and Q2. Remember, 50% means Q2 or the median value. And in the case of the year, we know that the most recent year is 2007, right, for that file, because in this case, we want to create a data frame only for the latest year, right, for 2007, for the max value. So that's why we have df 2007, the data frame, right? And in order to do so, we have df, and we filter with the condition that the year it's equal 2007. We use two equal signs because it's a condition. The single equal sign, it's reserved only for assignments. Okay, so let's create our data frame only for the most recent year, 2007, in our data set, and that's the data set where we're going to use for the remaining questions, right? So now we're going to create a histogram to visualize the shape of the life expectancy variable. So we use PLT, it's matplotlib dot hist, and the name of the data frame, the df 2007, and of course the variable name, life expectancy. So we visualize the histogram. In the x-axis, we have the variable, the life expectancy, and the y-axis is the count, is the frequency, like how many observations are within that bin, inside that bin. So we have like, there is a high number of countries that are, like between 70 and 80, right? We can see that here. You can analyze the shape of the distribution of that specific variable. So this one is skewed to the left or negatively skewed, right? It's not symmetric for sure.
Now you can see that there are some countries that are located here between 40 and 60 years life expectancy, and of course you will be concerned with those countries, right? Because that's low. A country with a life expectancy between 40 and 50 years, even though it's not the like 2025 like information, still to 2007 is not that old, right? To have a life expectancy of only 40 years. So let's continue. Let's create a box plot to also like keep analyzing our life expectancy. So let's do that. It's the important thing about the box plot is that it shows different information. It shows Q1, Q3, Q2. So here you have in the box the we have the three different quartiles. So the median is the line that is inside the rectangle, the box, right? We have the upper side of the box is Q3, and the lower side of the box that will be Q1. We also have the whiskers, and the whiskers are really important because they allow us to see if there are some outliers in our data. Okay, so it makes sense the median value, because if we check, it says 60.7, but that's using all information. That's not for 2007. So let's do it for 2007. So if we update it, we get that the life expectancy, the median value is 71.9. That means that 71 that above that value we have 50% of the country, below that value we have the remaining 50% of the values, and it matches, of course, our box plot. If you see that the median, the line, it's slightly above 70, right? So Q1 is below 60, right? And Q3 it's above 75. That's what we can see here. And again, with the whiskers, we can also see outliers. In this case, we don't have them. We don't have them. But later, we can now we can add the countries, the continents, just to compare them. So we can see like the life expectancy per continent. And the nice thing about using box plots is that we can see if they are different or if they look similar. So now we can see some differences here. So for example, if you check our box plot, remember that we have some countries that were below, right, the histogram, and also some were above. So Africa, if you notice, the median value, it's, like below 60, it's close to 50. So it shows like that median value for sure is different than other countries such as Asia, other continents such as Asia, Europe, the Americas, and Oceania. So here we can see also some outliers, right, which we will find later. You say that some distributions are the same or they look similar when the median are at the same level, but here that's not happening. The median values for each box, it's some of them are above, some are below. That means that there are median differences, right? They don't have the same performance. So we compare here the median values, but also variability. If you check Africa, it has a lot of variability, right? The whiskers are like they show that there is a high variation or a lot of possible values for that specific continent, for Africa. So here in the Americas we have one outlier. So that's a country that is performing really bad compared to countries in the same region. Same thing in Asia. You see that there is one country that is performing pretty bad compared to countries in the same region. So it's important to understand and to analyze the outliers because we can understand better, like what's happening. Okay, that's everything in this video. I'll see you in our next session.